So yesterday you were introduced to working with the chain rule exclusively with functions. Okay, an f function or a g function all nested inside of each other and working on kind of unwinding that or unwrapping that with the chain rule. What we're going to see today is that the chain rule can apply to graphical and numerical values, and the chain rule could be applied in those situations as well. So we'll just see some examples of how that all works. So let's take a look at these two individual graphs. Okay, so we have the graph of f of x, which clearly passes the vertical line test, so it's a function. And we have the graph of g of x, which also passes the vertical line test. So I want to talk with you about evaluating the difference between evaluating a function and evaluating the derivative of a function. So let's start easy. F plus g of 3 is the same thing as f of negative 3 plus g of negative 3. Okay, so rules of functions, you can separate those, and that's just reading the y value along the graphs. So the function value at negative 3 on the f function is right here, and so that has a function value of negative 3/2. And on the g graph, the function value at negative 3 is right here, so that has a value of negative 2. And so overall, you're looking at negative 7/2 as the value. Okay, so let's move on to how we would work that with the derivative. It's important that you follow the rules first before you start looking for numerical values. So f plus g prime, because this is an addition problem, we can separate this into f prime of negative 3 plus g prime of negative 3. So you can do that because it's addition. Addition in derivatives, you can take the derivative of individual pieces. Now the f prime of negative 3 is not the same thing as f of negative 3. Okay, remember, f prime of a value is the value of the slope right here at negative 3. Okay, so we want to evaluate the slope at that piece. And so the slope, if you're counting off rise over run, is up 3/2, and so this would be a positive 3/2. And then our g prime at negative 3, now we're looking for the slope value, so the slope value there at negative 3, and that slope value is 0, and so we have 3/2. Okay. Now let's look at what that would do if it was multiplication. If we're finding f times g of 1, the rules for multiplication, again, are pretty simple. F of 1 times g of 1. And we simply pull the y values off again. This time we're going to be going to the number 1, and we want f of 1 right here. So that's 5/2. And then times g of 1. So g of 1 is right here. Okay, g of 1 is right here. Okay, that's negative 1/2. So 5/2 times negative 1/2, so we're looking at negative 5/4. Now f of g prime. Now this is a multiplication. And you remember that with multiplication, also known as products, we have special rules for how that has to go. And so our rule is to start with g prime of 1 and multiply that by f of 1. So remember in the addition of the product rule, then we'll have f prime of 1 and then times regular g of 1. So it's important for you to know your rule first and then to go back and get the values at each piece. So we are supposed to be starting with g prime at 1. In other words, we're starting with the slope value right here at 1. And so if you count off that slope is up 3/2. So this is 3/2 multiplied by f of 1, which we look back at the f graph and we know that to be 5/2. And then we're going to add to that f prime at 1. Okay, so at that same spot over here, now we're looking for the slope value right here. And if you look at that slope, that's down 1 and over 2, so that would have a slope value of -1/2. And then our g of 1 value is also -1/2. All right, and so then we want to just simplify and clean that up. So 3 times 5, 15 over 4. And then plus the 2 negatives, plus 1 over 4. So 16 over 4, so we're just looking at a value of 4. Okay, so sometimes it's just as easy as separating and just multiplying the values together. But with derivatives, we needed this special rule and to do everything in the right order to get our correct answers. All right, let's look at how composites work. So you need to, again, know your composites. Remember that f of g of 2 is the same thing as f parentheses g parentheses 2. Okay, so just remember that the composite symbol with how the order goes. And when you're evaluating that, you always work from the inside out. So we go to the 2 value on the g graph. So our g graph, our 2 value is right here. So that would give me a value of 1 in the parentheses with f on the outside. And now we go to the f function, and now we're looking at the value of 1, and we know that that to be 5 over 2. Okay, how does this work with the composites, and you want to do the derivative of that? Okay, so I want you to remember that we are doing f of g of 2, and we're finding the prime on that. So we'll put I need an extra set of parentheses, and our prime goes out here. So it's f of g of 2, and that's prime. All right, this is going to require the chain rule. So this is a nested function, and we always work, remember, from the outside in. So the outside function that we're going to address first is this one. So we're going to do f prime of, and then we leave the inside alone. And then we move on, and then we're going to tackle the derivative of what comes next, which is g of 2. And then we have no other functions that we need to find the derivative of. Okay, so f prime of g of 2, and then, whoops, g prime of 2, the next derivative. All right, so now according to rules of evaluating composites, make sure you start with the inside value first, just like we did here. We started with the inside value. So we know g of 2 is 1, so that becomes 1, but it has parentheses still around it, and it's f prime around that, and then g prime at 2. Okay, so now we're looking at slopes, but we're looking at different x values and different function values. So on the f graph, I'll be looking at the function value of 1, and I want to find the slope there. All right, so we're looking at this piece right here, and we want the slope value, which is -1/2. But then for the g prime, so this one, now we're going to switch over to the g, but we want to be at the value of 2, and we want to know the slope value here. And the slope value there, you can tell, you should be able to tell that that is on the up 3 over 2 slope. So that's +3/2. So we're multiplying those two together. So overall, we end up with -3/4. All right, so hopefully that made sense to you in terms of making sure that you stick with what the rule is and then pull your numbers. Don't try and do numbers too fast. Okay, that same thing applies when you're working off of a table. Okay, so here's a table where you don't have a graph to look at and you don't have a function to work with. You just have you have sample values off of a table. Okay, all right, so here the instructions are using only the numerical information provided. Evaluate the derivative of each expression. So what expression are we talking about? This one. Find the derivative of that. Okay, so we work on the outside in. So we're going to have f prime first, and then we leave g of x alone. And then we work to the next value. So that would be the g prime, and then we have x. And then the derivative of what's still in the parentheses, which is the number 1. Okay, so now the x value is going to be 2. So then just kind of go back and replace those x values with the number 2, and then get what you need off of the table. So again, always start with the inside value, and we want g of 2 off the table. So here's the g function, and g of 2 is this value right here, is 2. So this can give me f prime of 2, and then times g prime of 2, and then times 1, which is not going to change the value. All right, so then we need f prime of 2 and g prime of 2. So f prime of 2 is 1/3. And g prime of 2 is -3. So the value is -1. Okay, let's do part B. Part B says we want to find the derivative of this function. Okay, now the first thing that might jump out at you is to say, oh, maybe I should try the quotient rule on that. But I might suggest to you that there's another way to write that. If you consider that instead of a quotient as the fraction 1/, that you consider that as g of x raised to the -2 power. And I think if you think of it that way, using a power, then applying the chain rule and working on the outside to the inside is going to be easier, because when you want to find the derivative, you simply pull the -2 down to the front. So let's find the derivative of that. So the derivative is going to be the -2 moving down to the front, the inside getting left alone, and then subtracting 1. So make sure we subtract 1 from that value, bringing me down to -3. Then I multiply by the derivative of the inside, which is g prime of x. And then I multiply by the derivative of the inside of that. The inside is x, and its derivative is 1. All right, and we're finding this at the x value of 3. So I can now erase or replace my x's with 3's. Okay, so now we want to know what the value of g of 3 is. So you're going to start with that value right there. And so g value of 3 is going to be this one now. That's the g value at 3, or in the x of the row of 3. So that would be -4. And that is raised to the -3. And then there's still a -2 out in front. And then g prime at 3, that's this one. So that would be multiplied by 5, and then multiplied by 1. All right, so to evaluate that, do your parentheses first. So -4 to the -3rd is the fraction 1/, -64, and then times 5. And we have 2 negatives, which is going to make a positive. We can reduce. We get 10/64, which ultimately reduces to 5/32. All right, same table, but some different things you want to take the derivative of. Okay, so here, again, I'm going to encourage you to think of this as writing it with a power instead of writing it with a root. Okay, so if you write that as parentheses f of x and you raise it to the half, I think if you think of it that way, it's going to be easier to apply the derivative rule, okay? All right, so we're going to take the derivative. The derivative will start with a 1/2 as its lead term. The inside's going to stay unchanged. I have to subtract 1 from that value, which drops it down to -1/2. Then I'll take the derivative of what's inside, which will be f prime of x, and then the derivative next is 1. Okay, always the rule first. Don't even look at the table, don't even get values off the table until you've done the entire rule. Now I want to replace all my x's with 2's. So this will become f of 2, and this will become f prime of 2. All right, so now we can use the table to our advantage. Okay, we want to find f of 2 first. So f of 2 is 8. So this will give me 1/2 times 8 to the -1/2. And then f prime of 2 is 1/3. And then times 1. So this is going to give me 1/6 if I put the 1/3 and the 1/2 together. And then the 8 to the -1/2 is 1/, remember it's not a negative number, it's a fraction, the square root of 8. So equivalent answers are okay. We could say that this is 1/, the square root of 8. Or if you simplify, it's 1/12 square root 2 if you simplify your radical. All right, last one. Once again, I'm going to encourage you to think of this in parentheses. So think of this whole thing as parentheses to the 1/2. But then also think of the f squared. Okay, that's a square, that's not a prime, that's a square. Think of that in its own parentheses as well. So think of it this way. Okay, the f of x function squared and the g of x function squared. All right, so when we're ready to take the derivative of this, we work on the outside first. So this outside's going to come down to the front. So then I'll lead off with a 1/2. I'll have parentheses f of x quantity squared and parentheses g of x quantity squared. And now I drop that power to a -1/2 because I've subtracted 1. The next part of the chain means I need to tackle the inside. And now it's time for that 2 to get pulled to the front and this square to get pulled to the front. All right, so now we're going to lead with a 2, and we'll still have f of x in the parentheses, and we'll decrease the power, so we'll subtract 1 from that, so that drops me down to 1. But then I still have to do the derivative of what's inside that parentheses, so that would be f prime of x, and then times the derivative inside that parentheses, which is 1. Now all of that is the leading part with a parenthesis in front of it. Now I'm going to add, and then I'm going to tackle the g part. So it's going to have all the same thing. I will have a 2, what's the easiest to do? 2 pulled out in front of the g of x. That'll be to the first. Then I'll take the inside of that, which would be g prime, and then the inside of that is 1. And then finally close out the parentheses. Now we've done the inside of everything. So that was a lot of calculus on that, a lot of being consistent with rules. Now you can use the table. So see, I haven't even touched the table yet. I haven't even looked at it yet. But I want to go back and change all these x's to the value I'm being instructed to use, which is 2. So I want to have a 2 here and here Here, this is 2, this is 2, and this is 2. And now I can get the values I need from the numerical table. So leading off with a half, I want f of 2, and I want to square that. So that'll be 8 squared. I want g of 2, which would be 2, and I want to square that, but that whole thing is to the negative half. So I'll deal with that in just a minute. Okay, now remember, this is not a prime, this is a first power, same as this. This was a first power. If you don't want to write the first power, you don't have to, if that's confusing to you, but it is a first power. All right, so now I'm going to have 2 times f of 2, which is 8 again, and then times f prime of 2, which is 1/3. And then plus 2 times g of 2, which is also 2, and g prime of 2, which is -3. So now what remains is for me to clean all of this up numerically. So this just becomes an arithmetic problem. So 1/2. Okay, so now we're going to have, this is 64. That's 4, so that's 68. But we also have the power. So this would be 1 over the square root of 68, which we could simplify. And then this is multiplied by, okay, and then we're looking here, 2 times 8 times 1/3, so that's 16/3. And then minus 2 times 2 times 3, so that's -12. And the rest of it is just simplification using common denominators and using maybe simplifying the radicals just to get that all the way in its most simple form. This is usually going to be a multiple choice where you're just trying to match your answer to the answer given. So if we look at that, let's see, so that would be 2 rad 17. And now we have 16/3, and I would probably think of this as 36/3 to help me with the subtractions. I'll have -20 over 3, and that will allow me to simplify a little bit more. Okay, so I'll have 1 over, let's do 4 rad 17 together, and then we'll have times -20 over 3. So I can simplify the 20 and the 4. So I think my final answer is -5 over 3 rad 17.